Hi, everyone. My name is Madhura Bhave, and I'm a member of the Spring team at VMware. In today's talk, I want to talk about what goes on behind the scenes when you run a Spring Boot application. So for those of you who are Spring Boot users, you know that Spring Boot does a lot out of the box to get your application up and running really quickly. And if you really understand what's going on behind the scenes, that can make your life as an application developer easier, and it can help you write and debug Spring Boot applications better. So I'm going to start off by creating an application from using Spring Initializer, just to reiterate kind of what that getting started experience is, what the out-of-the-box experience looks like. Spring Initializer is the easiest place to go to and bootstrap your Spring Boot applications. I'm going to be using the IntelliJ IDEA plugin for Spring Initializer. So I'll go here to New Project, click on Spring Initializer, and create a new project. As you can see, I can name my project with whatever I want. You can also use an ID of your choice, or even the web UI itself at start.spring.io. I'll select Spring Boot 3.2 M3. That's the current release that's underway for Spring Boot, and it will be generally available in November. And then I'm just going to select one dependency, which is Spring Web, which will basically start up the application on Tomcat. And then if I create the application, open it up in a new window. I'll just go over this application really quickly to show you how simple it is. There's not much to it at all. There's just the one Spring Boot Starter web dependency that we added. It's on version 3.2 M3, and I'm using Java 17 because that's the baseline change when Spring Boot 3 was released. And if we look at the main application class, it's probably familiar to all of you. It's a simple Spring Boot application class, which has one main method which runs the application. And I'll just run that just to show you what that looks like. Okay, so as you can see, the application started up on Tomcat port 8080. And we didn't really have to do much at all to get this application together and get us up and running really quickly. But obviously, there was a lot that Spring Boot was doing behind the scenes for us, which is why we didn't have to do much. But it's not really obvious what's going on behind the scenes. And don't worry, we can actually rebuild this application. And we're going to do that by starting mostly from scratch. And hopefully, as we go on, adding the pieces that we need for the application to run and handle our requests, you'll see kind of what Spring Boot does for you in order to get that application up and running. So moving back to the demo, in this, I'm going to close the application that we created from start.spring.io, and I have this demo application here. I've lined up all the commits that we need to develop the application step by step. So I'll be stepping through the commits and we'll be talking through them as we build the application. Again, just a quick look at the build.gradle file. It looks very similar to the one that we created using Spring Initializer. And it just has the Spring Boot Starter web and the test dependencies. The application class, again, looks kind of similar, but now we're not using the @Spring-Boot application annotation, which is the annotation that does a lot of the auto configuration that Spring Boot gives you, component scanning, etc. So we are just going to start, because we said that we're going to start mostly from scratch and not use any of the pieces that Spring Boot gives you and build those ourselves. We're just going to start with the @Configuration annotation. I'm still using the Spring application run method from Spring Boot just because I only have 45 minutes for this talk and I can't rebuild all of Spring Boot. So this will give us a quick way to run the application and get us going. So if I run this application now, let's see what happens. So it's trying to start up, and the application actually did not start up, and it failed. We get this nice failure analyzer from Spring Boot, and it failed saying that the web application could not be started because there was no servlet web server factory being defined in the context. Now, as you know, we've defined a Spring Boot starter web dependency in the build Gradle file, which means that we want this to be a web application, and Spring Boot tries to look for this servlet web server factory bean in order to create that embedded web server or embedded Tomcat that usually we see the application start up on out of the box. So before we kind of fix this error and move forward, I want to talk a little bit about how embedded servlet containers work and what Spring and Spring Boot do to get that started. So previously, before we had Spring Boot and before we had the embedded servlet containers, what used to happen was we had a servlet container such as Tomcat, to which we deploy a WAR file. And of course, you can still do that if you're using WAR files which get deployed independently to servlet containers. But the most common way and the easiest way to run Spring Boot applications is using a jar file which has an embedded servlet container. But going back to the WAR file, the servlet container would look for a servlet container initializer in the WAR file. Spring has its own implementation of servlet container initializer. And that implementation then looks for a web application initializer. So that's called abstract annotation config dispatcher servlet initializer. Basically, what this does is it creates and registers a dispatcher servlet with the servlet container. And the dispatcher servlet has access to the web application context, which contains all of the beans that you define in your configuration classes. But moving on with Spring Boot and Spring Boot's embedded servlet container support, we have a different kind of application context. It's called web server application context, and one of the implementations is servlet web server application context. I'm just going to talk about the servlet version here. There is a reactive counterpart, which is why we've kind of separated it out into servlet and reactive. So the servlet web server application context is different from the previous web application context that we saw in the case of the WAR file, because what it does is within the application context itself, it tries to bootstrap itself by looking for a servlet web server factory bean. And that's the error that we saw when we were trying to start up our application, is the application context couldn't find a servlet web server factory bean. The servlet web server factory bean is the one that can give us the web server, and the web server is the embedded web server that can be started, stopped, and initialized by the application context. Also, when the application context kind of starts up the web server, it gets these servlet context initializers, which are also from beans in the application context. So as you can see, the application context is kind of bootstrapping itself by creating, initializing, and starting up the web server by looking at beans within itself. So now that we kind of understand how embedded servlet containers work in a Spring Boot application, let's go ahead and fix this error because we need the servlet web server factory being defined. So I'm going to check out the next commit, which will add that bean. Yeah, so I'm adding Tomcat servlet web server factory because Tomcat is the default web server that we get when you create a Spring Boot application with Spring Boot Starter Web. And then let's go ahead and try and run it again. All right, so the application now started up on Tomcat port 8080 because we have this bean available. The application context was able to start up the web server and we don't get an error anymore. So let's go ahead and see if we can actually do anything with this application. If I go to localhost 8080, I don't get anything useful over here. I get a 404 not found. And that's because we don't have any controllers or any handler mappings to handle this request. It's just started the web server, but there's nothing else really that we've put together to handle that request. So as some of you might have guessed already, we need a controller that can handle it. So I've checked out the next commit over here and added a REST controller with a request mapping to /, and it's a very simple REST controller. All it does is it returns the string hello world. Now, let's restart the application again to see if we actually get something useful on localhost 8080. Okay, the application's up again. If I refresh the page, nope, still nothing. There is still a 404. Even though we have this REST controller, we're not getting our expected hello world output by hitting that URL. And the reason is that even though we've added the REST controller, we haven't really configured anything that tells Spring that it needs to pick up this REST controller and do something with it. So the next thing that we need to do is import configuration for Spring MVC that can handle these requests that can then be mapped to these annotated controllers. So the way to do that is using @enable web MVC, and that's going to import all of the Spring MVC configuration, kind of the plumbing that's needed to put together the bits that can then route the request to this REST controller. When you're using Spring Boot, this all happens behind the scenes. So Spring Boot will do it for you if you have the web starter on your class path. But because we're building from scratch and putting all the pieces together, this is what we need to add. Let's see if that works now. And go refresh our page. Nope, still 404. So as you can see, there's quite a lot of things that we need to do in order to get a simple REST controller working. And the last piece in the puzzle is adding a dispatcher servlet. Oops. Adding a dispatcher servlet. And the dispatcher servlet is what's going to kind of dispatch the incoming requests to the respective handlers that can handle requests for and route them to the annotated controllers. So we've added a bean for dispatcher servlet, and let's give that a try one more time. Refresh it, and there we go. We finally get the hello world. So of course, like to get this simple REST controller working and return a simple hello world string, there were a lot of steps that we had to go through to kind of put that all together. And it's one of the things that we don't realize when we're writing Spring Boot applications. We kind of just have to use the @Spring Boot application annotation, and Spring Boot will handle all of these things for you. But this is really kind of what's going on behind the scenes. So let's talk a little bit about how the dispatcher servlet works and go from there. So you remember the servlet web server application context that we have in a Spring Boot application context. Along with creating and initializing and starting up the web server, it also looks for beans of type servlet and filter and automatically registers them with the web server as it's starting up. For more advanced use cases, you can use beans of type servlet registration bean, filter registration bean, etc. So the dispatcher servlet is an implementation of servlet. And basically, when you have these annotated controller methods with request mappings on them, so such as foo and bar in this case, What happens when a request comes in is that the dispatcher servlet, which is the central dispatcher for all HTTP requests, knows how to route those requests to the right request mapping based on the handler mappings and the handlers that are configured. So that's why when we added the dispatcher servlet bean, the request was routed to the right request mapping, and we got our hello world response. Let's get back to the code and then try to refactor our code a little bit, because we've got all of these, we've added all of the beans that we need to get this application running, but we've kind of like put it all in this main application class, which can bloat up really quickly. It's not very readable, not very well organized. So let's kind of try and refactor the code a little bit. So the first thing I'll do is I moved the REST controller to its own class. If we need more request mappings in the future, we can add them to this class, and it's kind of self-contained. That's pretty much all that this commit did. It was move the REST controller to its own class, and then we're going to try and see if that still continues to work as it did before. Let's go back and refresh this page, and oh, we're back to our 404 not found. So even though we have this REST controller and we just moved it to a separate class, and we have all the plumbing that we needed, it still moved, it still gives us a 404. And the reason for that is that when Spring kind of tries to scan for the components that it needs to register it as beans, it does that from actually, let me go ahead and add the annotation first and then talk about component scanning. So the thing that we need to do is add this component scan annotation to tell Spring that it needs to scan for components in order to register them as beans. And components are things like your REST controller, controllers, repositories, services, etc. Because we didn't have this component scan annotation, Spring didn't know that it needs to register that REST controller as a bean. Again, let's just give that a go. Refresh, and then we're back to hello world. So what does component scanning really do? When we add that annotation to our application, why did it pick up the REST controller, and how did it work? So component scanning tells Spring that it needs to scan classes that are on your class path and register those as Spring beans. And by default, component scanning works from the package that is defined on the class, the package that the class that has the annotation lives within. You can customize the packages that component scanning works on using these base packages and base package classes attributes, but the default is the package of the class that the annotation is declared on. And of course, you don't see the component scan application if you use the Spring Boot application annotation, because it's hidden behind the Spring Boot application annotation. Let's see what happens during component scanning and how kind of this package structure works. So if we have our application that's kind of structured this way, where we have the application main class in com.example.demo, and then we have some other additional packages under com.example.demo, core, domain, config, etc. Component scanning, as we talked about, will scan all of the packages that are, or all of the classes that are nested under the package that that annotation is present on, or the class that the annotation is present on. So in this case, core, domain, and config are all in com.example.demo, and com.example.demo is the package of the application class where we've declared component scanning. But if we were to move config out of com.example.demo to just com.example, the config class would not, the components in the config package would not get scanned automatically by component scanning. Okay, so what we're going to do next as part of refactoring our code is we've extracted the controller out, but we're going to extract some of these bean configurations that we've got here. As you can see, these are kind of like probably common for all web applications because they're all going to need some kind of servlet web server factory bean. They're all going to need a dispatcher servlet. So maybe at some point this config package could get shared, which is why we can move these configurations to a separate package under config. And then we have separate configuration classes kind of to structure the code a little bit more. For the dispatcher servlet bean, the MVC configuration, which pulls in Spring MVC configuration, and Tomcat configuration, which pulls in the Tomcat server web server factory bean. As you'd expect, now that we've moved these to a separate package under config and they no longer live under example, if we run this application, like we just talked about with component scanning and how it works, we're back to the error that we got before where there was no servlet web server factory being defined in the context. If you remember how component scanning works, component scanning by default will only scan for components that are in the same package as the class that the annotation was declared in. Now there's this new package config, and so all of the beans in this config class are not scanned. So let's go ahead and fix that. What we can do is we can manually import these configuration classes and tell Spring about them. And then Spring will know that these are configuration classes and register the beans that are in them. So I'll just run it to make sure that it works. It started up because it found the beans since we've manually imported them using the import annotation. And now if I refresh it, I don't get the 404 and I get hello world instead. So great, but of course this import here on the main application class isn't really great because now your application needs to know about which configurations explicitly need to be imported. Since these are shared, let's say in some sort of shared config, your application should kind of be seamless for the application, and it shouldn't have to hard code them on this application class. So what we'll do is we kind of hide them behind meta annotation. And I think now you're kind of starting to see that this meta annotation, which I've called magic application, is starting to look like the Spring Boot application annotation. So on the main application class, we no longer have all of the component scanning annotations or the imports that we needed before, or the at configuration annotation. Instead, we've moved that to this meta annotation, and it all kind of lives nicely behind that one annotation, which makes your application code much more maintainable and much more readable. I won't run it. It'll work because all I've done is moved to the meta annotation. So let's look at what meta annotations are. So meta annotations are basically nothing more than annotations which are composed of other annotations. So as you saw in the one that we created, Magic Application, we annotated it with additional annotations such as component scan, the import that we currently have, and add configuration. And most Spring annotations can be used as meta annotations. You can use them within your own code as well. And they're used quite extensively within the framework. So you're familiar with at-rest controller. That's meta, and that's a meta annotation on controller. And get mapping is a meta annotation on request mapping with an additional method of get on it. And then when you have these meta annotations, how can you kind of configure the underlying attributes of the underlying annotations? And that's done using Alias for. So if you're familiar with this annotation over here that's on the screen, which is a Spring Boot application, it's meta annotated with component scan, auto configuration, and Spring Boot configuration. But how do we configure the attributes that are on these individual annotations? For example, if I want to configure exclude, which maps to the enable auto configuration annotation, that's done using this alias for annotation. So the alias for is specifies which annotation it maps to and which attribute of that annotation, underlying annotation, this attribute maps to. So in the case of scan base packages on Spring Boot application, it maps to the base packages attribute of component scan. Back to the demo. So the next thing that we're going to do over here is, even though we've kind of moved this import statement to this meta annotation, and now it's kind of hidden from our main application class, it's still, the configuration classes are still kind of hard coded over here. Nobody else can contribute additional configuration to this application. And if you're familiar with, or if you're a library author who's written custom auto configuration for Spring Boot, you're familiar with how you can register those auto configuration classes and get Spring Boot to pick them up. And we don't have any hard coding of the auto configuration classes in Spring Boot. So let's try and see how that kind of works and move away from the hard coding. So the first step is I've created this annotation called enable magic auto configuration. As you can see, it's named very similarly to enable auto configuration in Spring Boot, and move the import over to that annotation. One of the reasons for doing that, apart from having the ability to not hard code these configuration classes, which we'll do in a minute, is having this additional annotation gives us a way to separate out component scanning from auto configuration. So when we had Magic application before, and we kind of had the hard coded imports on this meta annotation, when our application used Magic application, it gets everything that Magic application does for you. So it gets the component scanning, it gets the imported classes. But let's say you want to use just the imports without enabling component scanning, because I know there are users who don't necessarily like to get component scanning, but they like to define the beans themselves. So there wasn't really a nice way to do that without having a separate annotation, which enables the configuration classes for you. That way you get that separation between component scanning and auto configuration. So instead of the imports on this meta annotation, now we've moved them over to this additional enable magic auto configuration annotation, and that gives that separation. We also have this magic configuration annotation. This is kind of new in, I think this was added in Spring Boot 2.7, I believe. Of course, not the magic configuration annotation, but the auto configuration annotation, which this kind of maps to in the Spring Boot world. And the reason for doing that is because we wanted to have this proxy bean methods equal to false by default for all of the auto configuration classes in Spring Boot, since that kind of improves performance when we don't need to necessarily proxy the bean methods that are in the configuration classes. Okay, so now that we have this kind of groundwork to move away from the hard-coded import statements over here, let's check out the next commit and see what that does. So back to enable magic auto configuration, instead of those defining those classes over here, the import annotation also lets you specify an import selector. So you can either specify configuration classes in the import annotation, or you can specify an import selector. And with the import selector, you get a lot more flexibility in terms of how you import things. You can add some logic around it and things like that. So we've moved over to an import selector at this point, and then moved those configuration classes that were on the import annotation to this import selector. Obviously, still kind of hard-coded in the sense that nobody else can contribute additional configuration to this application. So what we'll do instead of hard-coding them in this import selector is we'll use a separate file for it. And this file now lives in metainf.string, and it's named with config.magicconfiguration.imports. So I guess if you've been a long time user of Spring Boot, you must have seen, and if you've ever written your auto configuration, you must have seen auto configuration classes being contributed to Spring Boot using spring.factories. And this file over here that I've got here is kind of a replacement for auto configuration classes that were configured using spring.factories. The reason why we did that starting in Spring Boot 2.7 is because spring.factories was giving us some issues when we started working on the native stuff for Spring Boot 3.0. So we decided to move auto configuration to its own file instead of using spring.factories. And in the import selector, we're using this import candidates class to specify which file we need to look for to get the auto configuration classes. So the way it works is you give it which annotation you want to load those classes for. So in this case, our annotation is magic configuration, and the file is named according to that annotation's name. And then that's where it loads our auto configuration classes from. So we just specify all of the configuration classes that we need for this application in that file. You might have seen, if you're familiar with spring.factories, you might have seen Spring Factories loader being used before. But since we moved to this own dedicated way of loading auto configuration classes, there's a new class in Spring Boot called import candidates, which can do that. So yeah, kind of recapping what we just talked about, we have a way to specify advanced imports with the import annotation. So you can either specify like a regular configuration class, or you can specify an import selector, which gives you a lot more flexibility. Or you can even specify an import bean definition registrar, which lets you register beans directly in the application context. And then auto configuration imports that file. It's new in Spring Boot 2.7, and it's a replacement for spring.factories for auto configuration classes. There are other things that are configured in Spring Boot that still use spring.factories. But for auto configuration, we use this file, which is in metainf string in auto configuration.imports. Okay, so we're getting close to what we'd want our application to be doing, like kind of close to the getting started experience that we got out of the box. As you can see, this config package that we have here is shaping up to be a lot like what Spring Boot would have done for us behind the scenes, a lot like what Spring Boot's auto configuration does. So hopefully you can see kind of the thought process behind some of the Spring Boot annotations and what really goes on. The one thing that we've done here is we've added configuration for Tomcat, but as you know, with Spring Boot, you can configure a servlet container of your choice. So you can use Tomcat, or you can use Undertow, or you can use Jetty. So let's see how that works. If we were to specify another servlet container, and I've picked Undertow in this case, how would that work? And how would Spring Boot know which servlet container to configure? So it's another configuration class called Undertow configuration. And instead of the Tomcat servlet web server factory bean, I've configured an Undertow Servlet Web Factory bean. If I run this application, I think most of you must have guessed that it's going to fail with the error that it's unable to start the Servlet Web Server application context due to multiple Servlet Web Server factory beans. So it's not the case that it's missing, which is what we had before, but in this case, we have multiple Servlet Web Server factory beans, so Spring doesn't know which one to configure. And the way to do that is kind of make that conditional on some sort of specific condition when that particular bean should kick in. So in the case of Undertow configuration, we want it to be conditional on Undertow being present on the class path. So we've implemented this condition interface from Spring Framework, and we've said that if Undertow is present on the class path, only use this configuration in that case. And then we've told it to use this conditional with this add conditional annotation. Similarly, for Tomcat, we only want to use it if Tomcat is on the class path. So it's a very similar looking condition. And instead of the Undertow class, it's got Tomcat that it's checking for. So now that we've got these different conditionals on these classes, our applications should start up because Spring will know which Servlet Web Server factory bean to configure because we only have Tomcat on the class path. We don't have Undertow. So the Undertow configuration won't be picked up and Tomcat has started. But of course, since these conditions look very similar, the only difference is the class name that we've got here. Let's try and extract that into something that can be shared. So I've created this annotation called conditional on a class, very similar to Spring Boot's conditional on class annotation. And what this annotation does is it takes a class name. So that was the only difference that we had in the Undertow and Tomcat conditions. It takes that class name, and this condition will basically check if that class name is present on the class path, then the condition matches, and if not, it does not match. So I won't run it because it will work since we just moved it to its own separate condition. Okay, so recapping a little bit about conditions, there's an add conditional annotation, which is part of the Spring framework, and it's a very simple interface for writing your own condition. It just has one method matches, and you can kind of define what the rules are for matching that condition. Spring Framework uses conditions quite a bit. The profile annotation that's available within Spring Framework is a condition and it is a conditional. So if you have a specific profile that's active, that condition will match and those configuration classes will get picked up. Spring Boot uses conditions extensively within Spring Boot's auto configuration. So that's how Spring Boot knows which classes to auto configure when based on the class path. So there's conditional on class, there's conditional on bean, conditional on missing bean, so that if you define your own beans in user configuration, Spring Boot's auto configuration backs off. Conditional on property based on some properties that you might have specified in the Spring environment. And the nice thing about the conditions is that they're ordered such that the fastest ones run first. So if you have multiple conditions on a configuration class, say, and the fastest one doesn't match, it doesn't need to run the other slower conditions because one of them doesn't match. That configuration class won't be configured. Okay, so I did have a few other things in here which I've added kind of as extras, but I won't walk through all of them because I am kind of at the end of time. I'll just go through the slides for them. The code is all in GitHub, so you'll be able to see the code. It was mainly around how Spring Boot allows you to configure properties in like an application.properties file, an application.yaml file, etc. And we talked a little bit about Spring.Factories before in the way of how auto configuration classes used to be processed by Spring Boot. But now Spring.Factories is used for things like environment post processors, and environment post processors are what process or post-process the Spring environment and allow you to add those properties that are in an application.properties file or an application.yaml file to the Spring environment. So Spring.Factories is a simple way to discover implementations, and it's similar to the Java Service Loader, and it's a simple properties file in meta-inf Spring.Factories. All right, so I think what we just did here when we developed from scratch what we got out of the box when we created that application from Spring Initializer is we developed this config package, which did a lot of the things that Spring Boot does out of the box for you, which you don't really have to think about. But now you kind of know what the various pieces are that go on behind the scenes and how Spring Boot pieces all of that together to give you that running application. So the conditional on a class that we wrote maps to conditional on class within Spring Boot. The magic application annotation is kind of what Spring Boot application does behind the scenes. Enable magic auto configuration is the enable magic auto configuration annotation. Magic configuration, that's the new one with the proxy bean methods equal to false for the auto configuration annotation. Enable magic properties. We didn't really touch on that, but that's how the configuration properties get enabled. And configuration, all of the configuration classes that we wrote, such as the Tomcat configuration, Undertow configuration, those map to all of Spring Boot's auto configuration classes. So in summary, there's no such thing as magic. We basically rebuilt it. Of course, Spring Boot does a lot more, but we try to build a lot of the basic things that you get when you start up the application for the first time. You can follow the breadcrumbs in the code. So there's annotations. You can look through those annotations. If it's a meta annotation, there might be more annotations on it. There's import selectors, Spring Factories, conditions. And of course, you can always use the source, just step through what's really going on, because this is Spring is an open source project. So you can really step into the code to debug and figure out what's going on behind the scenes. And that's all I have. The code is on GitHub, and that's the link for it. Thank you.